Everyone, today we will be discussing on serverless architecture. My name is Sachin Chaube. Let's start the session. What is a serverless architecture? Okay, let's see multiple definition, but the best definition which I like is developer can write and deploy code. Remaining remaining rest all the infrastructure activity is managed by somebody else. That's the most easiest example which I like it. But let's see the other two example which are definitions given out there is serverless architecture is an approach to software design that allow developers to build and run services without have to manage the underlying infrastructure. What exactly they are trying to tell in this specific definition is that in a serverless architecture, okay, what developer need to do is they have to just build and run service. Apart from their service which they are building, they don't have to worry about the infrastructures out there. There is one more definition for serverless architecture. Let's go through that as well. That's what exactly they are telling is serverless architecture is a cloud computing execution model where cloud provider dynamically manage the location, provisioning of server. Developer can write and deploy code without worrying about infrastructure management and focusing purely on functionality. Exactly the same term. That's what developer will do is he will just write code and deploy, and his core functionality is the problem which he's trying to solve. That's it, and remaining the infrastructure part of it will not have to be managed by him. So there are three characteristics of serverless. One is invocations, how exactly it will be triggered and how exactly it will be work. So we call it invocations. Cold start. Do remember that serverless architecture, because you don't know, right, when the request is there. So what really happen is whenever the request or comes out there that there is an invocation out there, it will take few nanoseconds to start the service to process. Okay, that is cold start. So there are advantage and disadvantage. The advantage is you don't have to bear the cost, because in normal scenarios where you have a website which you host, you started a new company which have a very limited number of users who are accessing your website. So what you do is you create a container service and host it out there. In a month you only get 100 requests, okay, but your server was open 24 by 7 processing whether you get the request or not. In the cold start, whenever there is a request, it takes few milliseconds for first request to process, and the server is active for certain amount of time. Each provider has its own time from 5 minutes to 15 minutes based on which provider you have taken the services and working. Uh, Third part of serverless is it is concurrent. So what can happen is, for example, you have a request where you got all of the sudden multiple requests in the for your website, or for example you have any festival sale in your website and suddenly you get hundreds of requests. So your server can concurrently, but again in concurrency there is a limit. Each server or each provider give you certain limits. By the maximum it can go up to that level, but similarly it have its own drawback. Somebody hack your server, he just want to increase your bill for no reasons. So that can be one of the drawback which can happen with the help of concurrency. The focus or the benefits of serverless is focus on code, where developer only core focus is code. Second is cost efficiencies. What I said in initially, if you are a small organization which have built a new application or new services, you yourself know that at it will take some time for the service to up and work. So till that time, you can go for serverless. As your performance improve, you can increase when you have you. That's the third point is called automatic scaling. So as the request comes, the service will automatically expand and up to a level, okay, which can expand out there. So it's a in other way it's a beneficial for you, where if your service succeed, you get lots of requests. If it does not succeed, you have less number of servers, less number of instances, and you don't have to pay a lot. So cost wise it is very efficient. Auto scaling. So as if the request get increased, all serverless infrastructure whichever provider are there, they have the capability of automatically increasing the services or request as based on the request, but it have its own uh, uh, limit out there. Okay, so even that's one of the drawbacks. If you send a billion requests, it will not process all billion requests out there. So so it have plus and minus. Okay, so robust infrastructure, yes, you can rely on the infrastructure that if even you get 100 requests, all 100 will be processed, it will execute, and it will work as per them. Now security and security is always provided by the cloud provider, so there is certain we call as vendor lock-in. When whichever provider you go for serverless, you have a certain vendor lock-in where if you use their specific services, we will cover this part out there. Okay, uh, so which in a way it reduces the operational overhead, but it also creates the dependency on top of that. Drawback best is loss of control. One of the best example when I talk about serverless architecture, I talk about a taxi service. For example, you have to go from point A to B. You just board the taxi and you can go. Loss of control is when you are sitting in your own car with a chauffeur with you. You can make flexibility as per your need and convenience out there. Same is with serverless. uh, with each serverless, if you want certain features to be there, if they provide, then you can have. If they don't, you cannot have that. So this is one limitation of loss of control out there. Performance impact, as we started, one of the characteristics of serverless is cold start. So because of cold start, the first request, it will take certain times to response back, but next in the next 5 or 10 or how much is the timeout as per the provider, it will, the remaining response will be fast and immediate. Third is if you have to go for integration testing. In case of integration testing, there are 15 other services or 40 services where you want to test all the features are working out there. Uh, you cannot rely on the data out there, because being a serverless in the nature, okay, it the results or response will not be accurate, because it can be cold start, it can be repetitive request. So testing and the test results are not one of the best parameters to have. Last is what I was talking about, vendor lock-in. Each provider who give you serverless have their own technology to be implemented. We will cover this part in future. There are slides which we have discussed on the same topic. So there are vendor lock-in which you have to adhere, have to work. Okay. uh, the use cases are trigger based tasks, where uh, you want to automatically process, for example, you have a service called as where uh, a photo studio, where the moment anybody upload the image, based on it can be accessed on mobile, tablet, ipad, so you want to resize that. Similarly, for video, the you have a YouTube kind of similar services, where anybody uploaded the video for mobile, you want to do transcoding differently. For desktop, you want to do differently. You want for ipad, you want to do differently. um, for if it is geo region, so you want to perform because each geo regions use different services, different platform, so you want to have your video transform in that manner. So if you have that specific requirement, you can use serverless architecture for that. Building a restful applications, for restful applications, it's a very good example to go for it, where you make a request and you get the response back out there, where endpoints will handle the request. Okay, it's a very good cases. Third is asynchronous processing, or background job we call it, saying that if you have a tours and travels, where there is a ticketing system out there, when the package is booked, you want to send a invoice to the client saying that this is all your tour or itinerary out there. S- this part you can do. You have a data processing, where certain amount of data you want to pass from one server to other, that kind of. So you take a small chunk of data and pass it on, because you also need to understand serverless have a time bound. So from it have to process that activity in certain time frame, okay, based on which serverless provider you have taken out there. So that is one concern when you are processing data server job or handling long range job. So what you can do, if you have a long running job, you can That's what we have discussed, that you will take a chunk by chunk and do a long process, or use serverless to pass the data from one source to another. Very actively used is security checking. The moment these days it is very extensively used services. Even I have done few project on that, where any document which is uploaded on your server, you want to have a security scan to identify whether it's a virus or it's a genuine document. Okay, for that, serverless architecture or serverless base use case is a very good cases. In case of CI/CD, it's again one of the very advisable approach. If you go for any provider, it will be GitHub, GitLab, or any or CloudBees, whoever is the provider in the backend, they are using serverless architecture for each job or each step based on your requirement, whether they can go for job or steps, but mostly people go for steps wise, where they use the same, or job wise, where they can process a same job in a serverless environment. uh, as we discuss, we will now do the comparison. Okay, so in the market there are multiple, but I just trimmed down the service to 4 providers. One is AWS Lambda by AWS, Cloud Function by Google, Azure Function by Microsoft Azure, and last is custom provider, whereas you can build on your own is Kubernetes with Knative. So on what cases it can trigger? It can trigger by API gateway, S3, DynamoDB, notification service, queue service of AWS, CloudWatch, and many more. In case of Google Cloud Function, it can be called on HTTP request, Pub Hub, which is similar to API gateway but in cloud. Then is Cloud Storage, which is very similar to S3, Firebase, Firestore, and many more. In case of Azure, it is you can use with HTTP. Then there is a timer. Then Azure Service Bus. Then you can also use for Cosmos DB, which is similar to DynamoDB of AWS, Event Hub, and other. For Kubernetes plus Knative, it is HTTP, gRPC, Cloud Events, and more. For AWS Lambda, it support Node.js, Python, Java, C#, Go, Ruby, PowerShell, and some other custom sometimes. So these are there. For Google Cloud Services, it supports only Node.js, Python, Go, Java, Ruby, and .NET Go. Okay, so when you are planning for going for serverless, you have to make sure that you are building the solution on this platform only. Otherwise, it will not work. In case of Azure Function, it is Node.js, Python, Java, C#. Fhash is again one of the programming language used by Microsoft. Okay, PowerShell, TypeScript is an advanced version of JavaScript, and custom handlers. So they have their own handlers which are supported out there. Okay, and for Kubernetes plus Knative, because it's on-premise, whatever services you want to have it, or you want to build a service out there, okay, you can use it out there. Scaling, it is automatically based on incoming requests in case of Lambda. Similarly for cloud, same will be for Azure Functions. In case of Knative, it is based on horizontal pod autoscaler. Okay, again, as these are characteristics that it's are all yes, it is cold start, but you can further optimize. Okay, similarly with Cloud Function, Azure Function. In case specifically only case of Knative, you can scale to 0, where you can make it, you can run longer out there. Okay, but if you are making similar to containerization, so the core objective does not fulfill. Okay, so cold start have its own advantage, a core reason why you should go for serverless out there. It's in case of pricing, it's per user, the number of requests, duration, and the memory allocation. In similarly, all in all cloud provider, price model also remains the same. So it will be pay per use. Okay, either be Lambda or Google Cloud Functions, or for Kubernetes plus Knative, pricing model is as per your use, because it's the infrastructure will be managed by your side, and you can use as per your request. Come to the execution time. AWS Lambda, the default is 15 minutes. For Cloud Function, it's 9 minutes. In Azure Function, it's 5 minutes by default, but you can increase. Okay. And in Knative, because it's you can set your own limits based on the infrastructure in the backend. For state management, it is stateless by default, but you can manage with the help of DynamoDB or S3. For Cloud Function, it is better. You can use either Firestore or Cloud Storage. For state management, for Azure Function, it's same. Either you with Cosmos DB or Blob Storage. In case of Knative, as usual, it is stateless, and you can use external storage of Redis or Memcached to do that. For deployment, you have AWS Management Console, CLI, SDK, AWS SAM, Serverless Framework. In case of Lambda, for Cloud Functions, you can go for Console, CLI, and SDK, and Firebase CLI. For Azure Function, so if you see all of them, so all the technologies are specific to the provider, except Knative, because Knative you can do and work as per your requirement. Okay, but again, in case of Knative, but let's complete the Azure Function. So in case of Azure Portal, you can use Azure Portal CLI, CDK, Azure DevOps, and Serverless Framework. Similarly, for Knative is kubectl, Knative CLI, and GitOps tools. Okay, for monitoring, in Lambda you have CloudWatch. For Google Cloud Function, it's Stack drivers. In case of Azure, is Azure Monitor. And in case of native, you can go for Prometheus and Grafana, Elasticsearch, and Fluentd, because it's you have to do all your own. For CI/CD, you can use CodePipeline, Jenkins, and GitLab. For Cloud Function, you can have your they have Cloud Build. You can use Cloud Build. You can use Jenkins, or you can use GitLab CI/CD. For Azure Functions, you can use DevOps, GitHub Actions, and Jenkins. For Cloud Native, you can use Jenkins, Kitten, Argo CD as per that. For runtime, all support custom runtime, but you have to manage and configure out there, which is little pain to have that. It's not so simple and easy out there. For development environment, AWS have Cloud9 and local ID with SAM CLI. In case of Google Cloud Function, we have Cloud Shell and with local ID with function framework. You have to have that. In case of Azure Function, it's Visual Studio Code, and your local ID. Again, in this case, you also have to have Azure Functions framework to be there. For Knative, any local ID and Cloud Shell. For security, what are provided is IAM role is there. For VPC support is there, and API gateway with WAF, you can have that. What really is IAM role will be who can access, so you can have a service account which will manage out there. So you all on the security side, you also have VPC support, and you can have API gateway, which ahead of that is WAF, which will block. So one of the case which I discussed was if there is a billion request from the, so in that case WAF can identify that it's coming, it's a attack, so it will not allow the request come down to the Lambda function to do that. Similarly, for Cloud Functions, you have IAM and VPC Service Cloud. So especially for Cloud Function, I have already done one. Before that, there is one CD for cloud function I have already done and deployed out there, so you can refer if you want to go for serverless and check it out there. This is already there. Okay, so you can have IAM and you can have API gateway, again similar like WAF. You can also have WAF of cloud, which will stop that, and service VPC service control to do that. Similarly, in Azure function, you can have VNet integrations and you can use API management, which is similar to API gateway, and IAM roles to define and control out there. For Knative, it is you have to use role-based access control and network policies to do that. Network vendor lock-in, it's an all cloud provider. It's medium. Most of them it's the very, in case of Knative being open source, yes, it will be low. Thank you, and please subscribe to my channel if you like my content shared.